Okay, so welcome back to a continuation of the turning points. We made an introduction to the turning points, and we have stated that at any turning point, derivative of the function is equals to 0. And we have also stated that if you want to classify a turning point as either being maximum, minimum, or point of inflection, then you have to go to the second derivatives, and that if the second derivative is less than 0, then you're dealing with a maximum point. If the second derivative is greater than 0, you're dealing with a minimum point. And if the second derivative is equals to 0, then you are dealing with a point of inflection. So here I have 3 examples, and I want to write them down here. One is y. So we want to make a statement. The statement is identify and classify the turning points. The turning points. So 1, we have y is equals to 6 minus 2x minus x squared. 2, we can write y is equals to 12 minus 12x plus x power 3, and 3, we can write y is equals to x minus 1 squared x plus 2. So I think we can do which one? Let's do the second one. Yeah, the second one. I leave the first one. The first one is a simple one. So number 1, number 2, at the turning point, at the turning point, derivative of y with respect to x must be equals to 0. So what is the derivative? 0 minus 12 plus 3x squared. This one must be equals to 0. It therefore means that 3x squared is equals to 12x squared is equals to 4x is equals to plus minus 2. Okay, now the other thing that we want to do is, we said that a turning point is the coordinate x comma y, so we're looking for y. So when x is equals to 2, y becomes what? Becomes 12 minus 12 into 2 plus 2 raised to 3. So this is what? This is 12 minus 24 plus 8. So this is 20 minus 4. This one gives you a negative 4. When x is equals to a negative 2, y becomes what? So this becomes 12 minus 12 into negative 2 plus negative 2 raised to 3. So what is this? This is 12 plus 24 and then minus 8. So 12 and 24 gives you a 36 minus 8 must be 28. 28 and 8 is 36. Okay, so turning points are a point, it's x comma y, 0.2 comma -4, and b point, the point is has a -2 for x and has a 28 for y. The other thing is to classify them. Classify these points. So to classify, we said we must look for the second derivative. So second derivative must be equals to, so the first derivative we have seen, it's -12 plus 3x squared. That's our first derivative. So if you differentiate this a second time, what do we get? We get a 6x. So this one we cannot be able to tell whether it's greater or less than or equals to 0 if we do not supply a value for x. So not even when, if we can say at 2, -4, this is at the first turning point, the second derivative is equals to, you simply do 6 multiplied by 2, this is 12, it's greater than 0, and therefore this is a minimum point. At -2, 28, second derivative is equals to, so 6, supply a -2 there, gives you a -12, is less than 0, and therefore this is a maximum point. Okay, so yes, this is what we have, and I think even without attempting the other two, you can be able to work them out. The key here is first identify the turning points. How do you identify the turning points? First derivative. Once you get the first derivative equal to 0, you'll be able to get your points. Once you have those points, then you're left with the question, which of these points is a minimum, is a maximum, or is a point of inflection? So you go to the second derivative. Second derivative, once you get the second derivative, then you'll be able to determine whether a point is a minimum point, a maximum point, or a point of inflection. I hope this has helped you, and yes, you'll be able to work out other examples. But before I close it, I think we can look at question 3 quickly and see how to work it out. So question 3. Question 3. So we are in question 3. So question 3, this is question 3. At the turning point, the derivative should be equals to 0. So what is the derivative? This one, you have the option of opening. If you do not want to open, you can use the product to work it out. So I prefer to use the product u prime v plus uv prime. Now this one is equals to u prime is equals to 2 into x minus 1, then x plus 2 plus u is x minus 1 squared multiplied by v prime, which is 1. Okay, 1, like that. So the answer becomes, what does it become? It becomes 2 it becomes what? Okay, let me do this. Let me factor out for the ease of equating it to 0. I want to factor out x minus 1 like this. It's common. Then I'm left with 2 times this, which is 2x plus 4, and then plus x minus 1 like this. So what does it become? It is x minus 1, 3x, and then plus 3. This one is supposed to be equals to 0 at the turning point. This is equals to 0. Now I hope you see why I've decided to factor out x, is so that now I can use the method of quadratic to solve this one. So it's either, let me write it up here so that I have enough space to write. It's either that x minus 1 is equals to 0, yes, or 3x plus 3 is equals to 0. This implies that x is equals to 1, or 3x is equals to minus 3, which means that x is equals to minus 1. So again, when x is 1, what is y? So y becomes what? You write 1 minus 1 squared multiplied by x plus 2. This gives you a 0. When x is equals to negative 1, what is y? Y becomes, this is a minus 1 squared minus 1 plus 2. What does it give us? This is a minus 2 squared is 4. Multiplied by 1 gives you a 4. So turning points are A 1 0 and B negative 1 4. Now the remaining task is to classify them. So classification. Classify these points. So second derivative is equals to, we've already have the first derivative, so we want the second derivative. So second derivative, how do you get the second derivative? We can open the first derivative here to become 3x squared plus 3x 3x minus 3. What does it give you? 3x squared minus 3, because this one gives you 0, is equals to 0. So I'm dealing with a derivative which is 3x squared minus 3, and therefore it gives me 6x. Second derivative is 6x. It's the derivative of 3x squared minus 3. So this is what I have. So this is what now gives me this derivative of this one. The derivative of this gives me 6x, and therefore we can be able to work it out like this. So at 1 0, second derivative, and you can also write second derivative as y with a double prime. So second derivative is 6 multiplied by 1, which gives you a 6. 6 is greater than 0. This one is a minimum point at -1, 4. Second derivative can also be written as y with a double prime is 6 -1 is equals to -6 is less than 0. This means that this point is a maximum point, and that's how you work it out. And I hope from this point onwards you should be able to deal with any stationary point. A turning point is also known as a stationary point. So you'll be able to apply this in many other areas of application. You can apply this in business, whereby you have like in business, you have a function, a curve, which is the cost. And if you draw a cost curve, you'll be asking yourself, where do you have a minimum cost? Or you can even draw a profit curve, and then you ask yourself, where do you have a maximum profit? So it's the same idea of letting the derivative become 0 at the turning point. So have a nice time, and then we meet again in the other applications.